We're live and we continue solving our tasks with I'm sharing my screen. Let's check our neetcode. What do we have? So we have trees and we have the next task that's called node in BST. So let's check what we should actually do here. All right, so so here we need to delete node in BST. So let's revert our task and let's write. Given a root node, so we're given a root node that is BST, and we have to delete the node with the given key in the BST and return the root if possible. Basically, the deletion can be divided into two stages. So first, we search for node to remove, and if the node is found, we actually delete this node. So for example, we need actually to have, I think we need to have a dummy node. So we create a dummy node with -1, with 3 node. So it would be dummy. And then dummy, for example, left would be equal to root, right? And then we have this dummy node. And then we need to find the root nodes that we need to delete. And when we found a root node, so here, for example, we have 0, so there is no root node, and we just can return a result from here. But when we found a root node, sorry, not root node, but the node that we need to delete. So for example, we found 3 here, and return this 3. So this 3 is actually not, it's not something that we actually need to delete. And we can always take, like, when we remove 3, for example, we can make like 2, we can make like 4, but 4 here can be like different. Because we left with this 2, and here it's like another nodes that are left. So we need somehow to combine these 2 values as well like this 5. So so if we take, for example, here 2 into the, so I can just describe maybe how it will work. So for example, I have 5, then I have 3, then I have 2, or even like, for example, I have 8, then I have 6, then I have 4, and under 4 I have 2, 3, and here I have 7, for example, right? And my task is to delete 6. So when I delete 6, I have 7, and here, for example, I even can have 8, right? And something here. So I need to merge somehow these two trees together. And how can I do? I can, if I have here, let's say 6, here it would be like A7, right? Then I have 8, then 6, and 9, something like this. And my task is to return remove 7. So what I can do here, so I can put this 8 here. And then put this 4 under 6, for example. So find the most left value and put this on the left. So it's one option. Another option, I can, for example, put 4 and then find the right and put this one. So it's quite complex, actually. What other options we can have? So other options BST. So BST, it's actually we find this node in logarithmic time. So it's fast. Also, if we will see that the node value, the number of nodes is 10 in the 4th power. So quadratic could work here. But do we need actually this quadratic? So I think even linear should work. So for example, we can flat our tree and then rebuild actually this tree once again. So I think it would be the best scenario here. But what if we will just find this 7 and we will find the 7 and what we can do then? Let's think. So I need somehow to remove it. All right, so let's think. Let's think. I think that when I will find, then I need to actually call remove operation, and this remove operation should actually merge these two trees. So let's so what I recommend. So I have the global function where I just the global function where I just iterate over my tree, and if I see specific one, like if I found this keys, then I call remove, and remove it's actually I just will merge these two functions. So this delete node, let's say that it would be my global one, and here I will have like tree node remove, and how this remove will look like. So I have like tree node to remove, and Yeah, and then I will try to merge them together. So merge together, like find most left on the right, and second one it's to put left to the found node. So it will be removed on delete. I will do this following. So I need to return root, and if root is equal to null, I will just return null. If root value is equal to key, is root value is equal to key, I will return remove root here, else if root value is greater than key, then I will probably return delete node, delete node for root left, and key, else return delete node right. Okay. Yeah, something like this. Or even what I can do, I think that I can do like this. So root left would be equal to this one, and root right no, if it's BST, I think it should work like this, right? So for example, if I need to return so I have something like this, so I need to return 10, so I will call remove, and I will return from here. No, I will return actually the correct value from here. If I need to return 7, so it means that I check root value, it's 10, it's greater than key, so I go to left, I call this function, so I remove 7, but I don't include it, so so in this case root left will be equal to this one, and here root right will be equal to this one, and here I just return root. Yeah, something like this. And now let's implement this function. So if node right is equal to null, then I just return node left. Okay. If the same, I think, if node left is equal to null. No. If node left equal to null, I return node right. Otherwise, I need to find most left on the right. So I take 3 node right, so it would be node right. And what I need to do, I actually need to find most left on the right. So while right so I take like or left is not equal to null. Let's see like this. I like right left equal to right left. Okay, now if it's equal to null, then I do like right left equal to not left. Okay, and then I just return this node. Ah, no, I need to return this. So I return node right. Yeah, something like this. All right, so let's run. Let's submit. Okay, so we're done. So actually it works quite fast, because here we find in logarithm time, and here it's actually can be, yeah, so it's pretty fast. Run, let's check our previous implementation. So actually almost the same. So first we check all these values. If it's equal, we do like this, right? So the same to function, then we find the mean, so the same while loop, and root value, found value, delete node. Yeah, I think it's this even more complex, so I think current implementation is better. So we are done for today, and see you tomorrow.